in section 3, we're going to talk about shapes of distributions. So that means when you're looking at a graph of a set of data that is one variable, you kind of want to look and see, okay, how is that data shaped? So we have 6 teams here from the NFL and their number of wins from the 2017 season. And so something we might notice about the win totals from the teams is that they're all very close. They're all very similar. 9, 10, 11, those are all very close together, very similar amount of wins. So if I'm going to make a dot plot of this, I can pick an arbitrary starting point. I'm going to do 8, 9, 10, 11, 12, just put some numbers on there. So I have 3 dots above 9, 2 dots above 10, and 1 dot above 11. So not a lot of data there, but something I might notice is like the most number of wins is 9. Something else I might notice is that very few wins at the high end. So that means 11, 12. So not a lot of wins up there. So let's go ahead and calculate our mean and our median. So just to review, for the mean, we're going to add up all of our numbers. So we're going to do 9 plus 9 plus 9 plus 10 plus 10 plus 11. We're going to get 58. Then we're going to divide by 6. And we're going to get 9.67. For our median, I'm going to place my numbers in order. And now I'm going to start crossing them off at the ends. And I get my median is 9.5. So look, 9.5, 9.67, those are pretty similar values. Not a lot of variation between my mean and my median. Now, let's go ahead and we're gonna talk about Cleveland. So during the 2017 season, Cleveland had 0 wins. So now we're gonna remake our dot plot, but this time we wanna include our 0. So this time I'm gonna start at 0 and I'm gonna go up by 2s. Just because if I went up by 1s, I wouldn't have enough spaces, really. So I have a 0, but I still have my 3 9s, my 2 10s, and my 11. So now, if I'm recalculating the mean, I still have 58, because if I add a 0 into my data set, it doesn't change that. But now instead of dividing by 6, I'm dividing by 7. And that is going to lower my mean significantly to 8.29. Now my median, I'm going to have my 0, then I'm still going to have my 3 9s, my 2 10s, and my 11. Now when I cross them off, I end up with just 9. So yes, my median changed. It went from 9.5 to 9, but not a huge difference like my mean, which went from 9.67 all the way down to 8.29. So a lot bigger of a change in my mean than my median. Okay. Now we're gonna go back and we're gonna go without the Browns back to our original data set, and this time we're gonna include the Patriots win total from 2017, which is 13. They won the Super Bowl that year. So I'm going to go ahead. I'm going to do kind of the same thing I did the first one, 8, 9, 10, 11, 12, 13, 14. So I still have my 3 9s, my 2 10s, my 11, but now I also have my 13. This time my mean is going to change in the numerator, so I have to do 58 plus 13, and I'm going to get 71 divided by 7. And I'm going to get 10.14. And for my median, I'm going to have my 3 9s, my 2 10s, my 11, and my 13. And I'm going to end up with 10. So again, median didn't really change a whole lot, 9.5 to 10, but my mean changed quite a lot more. It went from 9.67 all the way up to 10.14. So what this tells us is how a value is added to the data set can affect our mean or median and our shape of our distribution. So when the mean is greater than the median, we say something is skewed right. So what that means is there are more values at the higher end of our distribution. So if I go back to the most recent example I did, I draw a graph, I can see a lot more higher values at the right side, which means it's skewed right. On the reverse side of things, if the mean is less than the median, it is skewed left. So if you go back up to our example, I'm going to move here real quick. We go to our example where we had our 0. I start low, then I go up and come back down. That's something where it's skewed left. I have a lot more smaller values at the lower end of my distribution than the higher end. And then the last one is if the mean and the median are about equal. And the important term here is about equal. They don't necessarily have to be exactly the same, but they're going to be really, really close, like our first example. 9.5 and 9.67, very close mean and median. We say that that distribution is symmetric, which is kind of like your bell curve. So I'm going to just go ahead and quickly draw just examples. So we have right skewed. So that's going to be when you have a lot more data at the right end, a lot fewer data at the right end. We have left skewed, which means there's a lot fewer data at the left end. And then we have symmetric, which is where you get that bell curve. You've got pretty much an even amount of values at the low end and the high end, so you get the bell curve. So being able to look at a graph and determine which direction it's skewed or if it's symmetric, but also being able to look at the mean and the median to determine if something is skewed or symmetric is also important. So let me know if you have any questions.